Let's dive into Bayes' theorem. It helps us update our beliefs when we get new information. This concept is widely used in fields like spam detection, medical diagnosis, and machine learning. Let's explore its significance and how it works. Before we get into Bayes' theorem, we need to understand conditional probability. It tells us how likely one event is given that another event has already happened. For example, if it's cloudy, what's the probability it will rain? Let's explore. Here's the formula for Bayes' theorem. P of A given B is equal to P of B given A times P of A divided by P of B. This formula helps us refine probability estimates when new data arrives. Let's see Bayes' theorem in action. Imagine a medical test that TTM's 99% accurate and only 1% of people have the disease. If you test positive, does it mean you definitely have the disease? Bayes' theorem helps us get the real probability. Bayes' theorem is everywhere. It's used in spam filters to detect unwanted emails, in medical diagnostics to refine test results, and in AI for classification tasks. Its power lies in continuously updating probabilities as new information comes in. To summarize, Bayes' theorem helps update probabilities when new information is available. It relies on conditional probability and is essential for making informed decisions under uncertainty. Moving forward, you can explore naive Bayes classifiers in machine learning, dive into Bayesian statistics for deeper insights, and see how it's used in decision-making frameworks. The applications are vast and incredibly useful.